Hey everybody, welcome back to chemistry. And so with this presentation, what I want to do is just finish up all that we have to do with compound nomenclature. So the first thing I want to do in this presentation, I want to show you how to take a formula for an ionic compound and turn that into a name. And then what I'm going to do is talk about how you take a name for a molecular compound and turn that into a formula. And then I'll go over how to take a formula for a molecular compound, convert it to a name. And then finally what I'm going to do is we're going to figure out how to take a formula for an acid and convert it into a name. So let me start by talking about how do we take an ionic compound formula and convert it into a name. And so let me go through these rules that we have here on the computer. So you'll see a bunch of formulas for ionic compounds, and you're going to have to convert them into names. There actually are about 4 types of compounds that you'll have to do this for. And so you sort of have to recognize the type of compound that you have and then remember the rules to convert that compound formula into a name. Let's look at possibility A. So some ionic formulas, what you'll have is a monatomic cation and a monatomic anion in the formula. So a good example of that is NaCl. So let's talk about why NaCl is sort of a matching of a monatomic cation with a monatomic anion. So here we have Na, and so you might remember Na as an ion is Na plus, and then Cl as an ion is Cl minus. And so both of these are ions because they both have charges, and they're both monatomic ions because you can only see one atom carrying the charge. So how do we provide a name for NaCl? So this is what you do. So to figure out this name, the metal cations in the name will get the same name as the name of the element. The nonmetal anions get the name of the element but modify with an "ide" ending. So as an example of NaCl, if you're trying to find the name for NaCl, you don't use the words sodium chlorine. Instead, you modify chlorine to chloride. And so the name of this compound is sodium chloride. Okay, so another class of ionic compounds that you might be looking at is a formula where you have a monatomic cation match with a polyatomic anion. So we have an example there with K2SO4. So I'm kind of hoping that you remember that the K there, the potassium, is a monatomic cation. It is K+, while the SO4 there is a polyatomic anion. So it's SO4 and it has a 2- charge. So how do you figure out the name for that compound? So here in the compound name, the metal cations get the same name as the element. The polyatomic anions keep their name in the name of the compound. So you don't change the name of the polyatomic anion at all. And so you figure this out and you will find that K2SO4, when you write out the name for that, is going to be potassium, and then again just write out the name for the polyatomic ion without modifying it, so it's sulfate. So the full name is potassium sulfate. Okay, now another possibility is that you'll have an ionic formula where you're matching a polyatomic cation with a monatomic anion. And so there's an example there. It's NH4S. And so what do you do about that one? So here, when you write out the name of this compound, the name of the polyatomic cation is the same. You don't modify that in any way. And then you add to it the name of the anion. It's going to be the same as the element, but change it to an "ide" ending. And so there, NH42S, you're going to name that as not so much ammonium sulfur, but you have to remember that there, the anion, you have to change the sulfur to an "ide", so it's going to be ammonium sulfide. So in these examples, what we were looking at were monatomic cations, and those monatomic cations were monovalent, meaning that those cations can only have one possible charge. So for example, when we were looking at sodium chloride, sodium, when it's charged, can only be a single positive. It can never be anything else. Now, when you're dealing with cations that are polyvalent, then we have to use slightly different rules. So I need to go over that. Okay, so again, all the examples I went on the previous slide were when the cations were monovalent. Now, when you're dealing with a formula with a polyvalent cation, then it gets a little bit more complicated. And so what you have to be sure to do is when you write out the name of the formula, you indicate what the particular charge of that cation is in the formula by using a Roman numeral. So most of the transition metals are polyvalent and so can have more than one cation charge depending on the anion it's bound to. So for example, iron can have one or two different charge states depending on the anion it's bound to. It could be either be Fe2 plus or Fe3 plus. Copper can either be Cu plus or copper 2 plus, for example. But what you should do for this class is assume that all transition metals are polyvalent with the exception of the four following monovalent metal cations, which are Sc3+, Cd2+, Ag+, and Zn2+. They can only have those charge states that you see. And again, what you're going to have to do is if your metal in the formula is polyvalent, you're going to have to figure out what the charge of that metal is and then include that in the Roman numeral of the name. So for example, what is the name of FeCl3? So if you were to write iron chloride, you would not get full credit for this answer. And the reason is this. Iron here is not a monovalent cation. It is a polyvalent cation. And you may know that iron can either be +2 or +3. So what you're going to have to figure out is it better to say that this is iron Roman numeral 2 chloride or iron Roman numeral 3 chloride? So how do you figure that out? So the way you do that is as follows. The first step is in that formula you look at the anion, which is chloride. Now chloride is monovalent. It can only have a particular charge, and that particular charge is -1. Now if you look at FeCl3, you will see that there are 3 chloride ions there. So the total charge contributed by chloride ions is -1 per chloride times 3 chloride ions. So it's a total charge contributed by the chloride of -3. So the total charge contributed by the iron should be +3, but there's only one iron atom there. So that one iron ion should have a charge of +3. So you figured out that the iron in FeCl3 is +3. And so the correct name for FeCl3 is iron 3 chloride, which is what I've written down there. Okay, so now what I want to do is go ahead and practice taking ionic compound formulas and writing names for them. And so let's do the first one here. So the first one is KCl. So can we figure out a name for that? So the first thing we want to do is look at the formula and see what kind of ions are there. And so what you can see, or maybe what you can remember, is that K is K plus and Cl is Cl minus. And so both K plus and Cl minus are monatomic ions. So do you remember how to name a compound where the formula has 2 monatomic ions? So the first thing what you do is you write out the name of the metal, because the name of the metal ion is going to be just the same as the metal. And the next thing you want to do is you're going to have to write out the name of the non-metal anion. But remember, in this case, you have to take the elemental name and then change the suffix to "ide." So you could take the elemental name, it would be chlorine, but what you're going to have to do is change "ine" to "ide." So the name of this compound is potassium chloride. Okay, so let's go to the next one. So there we have NiS. And so S, you can look up its position here in the periodic table, and you might remind yourself that when S is charged, it will have a 2- charge. So let me write that here. Now let's talk about nickel. So let's look at the location of nickel. So nickel is here. So one of the things you're going to have to notice is that nickel is a transition metal. And so this block of elements here are the transition metals, and you can sort of see nickel as a part of that. So what you're going to have to assume for this class is that with the exception of 4 metals that I mentioned, anytime you have a transition metal, it's going to be a polyvalent cation. So nickel is got to have some kind of charge, but you don't know what it is. And so when you write out the name, you're going to have to at the same time figure out what the appropriate charge of nickel is and then include that as a Roman numeral in the name. So what I recall is nickel usually is either +2 or +3. So you're pretty much in this question, you're going to have to figure out whether the name is nickel 2 sulfide or nickel 3 sulfide. So let's see if we can go ahead and figure that out. Okay, so what you can see here in this formula here, NiS, we have one sulfide ion, and the sulfide ion has a 2- charge. So the total charge contributed by a sulfide in this formula is 1 sulfide ion times a 2- charge, and so the total charge contributed by sulfide in this formula is 2-. That means the total charge contributed by nickel needs to balance that. It's got to be 2+. And so there's only one nickel there. So what must be the charge of that one nickel so that it gives you a total charge of 2+? Well, nickel must be 2+. So you just correctly figured out what the charge of the nickel ion is there. So the name of this compound is nickel 2 sulfide. Now let's step back to the first one, which was potassium chloride. So you might ask, well, why don't we have a Roman numeral after potassium? And the reason is, you might remember when we are dealing with a monovalent metal cation, then we don't need a Roman numeral. So let's confirm that potassium ion is a monovalent metal cation. So potassium is here. And so what you can see is potassium is outside that transition metal block. And so it only is going to have one possible charge. And that one possible charge is going to be a single positive. So it's a monovalent cation. And so when you have a formula with monovalent cations, they don't require a Roman numeral. Okay, so let's go on to number 3, which is Ca3PO42. What is the name of that? So one of the things you'll see here when you look at this is you have calcium, which is a monatomic ion, and then we have phosphate, which is a polyatomic ion. So do you remember how to name that? So what you do is you take the name of the element of the metal, and that will be the same as the name of the ion, so it's calcium. And then the polyatomic ion we just use without changing the name, so it's phosphate. Okay, so for the next one, number 4, we have NH43P. And so it looks to me that we have a polyatomic cation followed by a monatomic anion. So to name that, you write out the name of the polyatomic cation without modifying it in any way. So this is ammonium. And then with the monatomic anion, you're going to have to take the name of the element and modify its suffix with an "ide." So we have a P here, which is here in the periodic table. This is phosphorus. So we have to change phosphorus to phosphide. Okay, so for the next one, number 5, we have copper sulfate. And so here we have a monatomic cation with a polyatomic anion. Now we have to be careful about this. Copper, you might remind yourself, is a transition metal. It is here. And so it is not one of those 4 exceptions. And if so, then it's going to be a polyvalent cation. And so what I recall is copper can be of either one of 2 charge states. It can either be a +1 state or a +2 state. So you pretty much have to figure out whether the name for this compound, is it copper 1 sulfate or is it copper 2 sulfate? So how do you figure out which charge state the copper is in? Again, look at the anion first. So the anion is a polyatomic ion sulfate. It has a -2 charge. There's only one of these anions here. It's not 4. 4 only applies to the oxygen here. So the whole sulfate ion here has a total of -2 charge. And so the copper must balance that -2 charge by having a +2 charge. And so we only have one copper atom there. So what must be the charge of that one copper atom so that its total charge is +2? So to balance that sulfate -2 charge, the copper atom must have a +2 charge. So the name of this should be copper 2 sulfate. Okay, the next one, it is number 6. We have Ag2O. So you have to be careful about this. Let's see where Ag is. So Ag is here. It is a transition metal, but this is one of the 4 exceptions where the metal is not polyvalent. It is monovalent, meaning that silver only has a particular charge, and that charge is going to be positive. So once you have identified silver as having one charge that's monovalent, then the name does not need a Roman numeral. So this is going to be silver, and then it won't be oxygen, it'll be oxide. Okay, the next one, PdNO32. What is the name of that? So let's first figure out where palladium is. Palladium is a transition metal. It is not one of the 4 exceptions that is monovalent, and so palladium itself is polyvalent. So you're going to have to figure out the charge of what the palladium ion is in this formula. So we have nitrate here, and so you might recall that nitrate, one ion of nitrate is a single negative charge. Now, in this formula we have 2 nitrates, and so the total charge contributed by nitrate is 2 minus. Therefore, this whole charge contributed by palladium should be 2 plus. And we're only having 1 palladium ion there. And so that 1 palladium ion must have a charge of +2 to balance the 2 negative charges from the nitrates. So palladium's charge is 2, and that needs to be included in the name. So it's going to be palladium 2 nitrate. Okay, so for the last one, number 8, we have NH4OH. So the key thing here is to identify that we have a cation that is polyatomic. It's ammonium. And we also have an anion, which is polyatomic, which is hydroxide. So if both the cation and the anion are polyatomic names, we write out those names without modification. So the name for this is ammonium hydroxide. Okay, so we move on. Okay, so now we're going to look at molecular compounds. And so molecular compounds are a little bit easier to find formulas for. And one thing you do have to memorize for molecular compounds is you have to memorize the names of the prefixes that you're going to use to recognize how many atoms of each element there are in a molecular compound. So if you have a molecular compound and it has an element, it has the prefix mono in front of it, that indicates that there's 1 atom of that element. If you have the prefix di in front of the word element, there are 2 atoms of that element. Tri, 3 atoms. Tetra, 4 atoms. Penta, 5 atoms. Hexa, 6 atoms. Hepta, 7 atoms. Octa, 8 atoms. Nona, 9 atoms. And deca, 10 atoms. So you have to memorize those prefixes. And one thing you could do is you can put the name of the prefix on a flashcard, and then on the reverse side just indicate the number of atoms it indicates. Okay, so let's go ahead and find formulas for these compound names. Okay, so the first thing we might want to think about is, are these ionic compounds or are these molecular compounds? And so the way we tell again, and you should always be doing this, is look at the names of the elements and then you figure out, is it a nonmetal and a nonmetal, which would make it a molecular compound, and then you use the prefixes. If it's a metal and a nonmetal, it's an ionic compound, and you wouldn't use the prefixes. So let's just kind of look at the name here. So we have carbon here, and we have hydride here. So carbon is a nonmetal. Hydride is a nonmetal. So in the name we use prefixes, and we can see them. There's tricarbon and there's octahydride. So the formula is pretty easy. If it's tricarbon, you write C3. Octahydride, hydride is hydrogen, right? H here, 8. The next one, dihydrogen monoxide. So hydrogen is 2, monoxide, 1 oxygen, so that's water. Okay, the next one is dinitrogen pentoxide. So we have nitrogen first, and we have 2 of them. Oxygen next, and we have 5 of them, so it's N2O5. The next one, carbon tetrachloride. If you see no prefix in front of the elemental name, it is just 1 atom. So it's just C, no subscript, just 1 atom. Tetrachloride, Cl4. And then the next one is diphosphorus hexahydride. So it's going to be P2, and the hydride again is hydrogen, H6. Okay, so we move on. Okay, so now what we're going to do, a little bit trickier, is take the molecular compound formula and convert it to a name. So let me show you how to do that. Okay, so first one, we can see it's a molecular compound because nitrogen and oxygen are both nonmetals. Now we have to give it a name. So you can see that the first element has 2 atoms. So we're going to write dinitrogen, And then the next element just has one atom, so we write monoxide. Okay, now the next one is a little trickier. There's this weird rule with figuring out names for molecular compounds, which you need to know. So you might look at that and you say, oh, okay, that's easy. That's mononitrogen monoxide. Well, the weird rule is this. If the first element has only one atom, you leave out the mono. Now, that's not true for the second element. If the second element has one atom, you include the mono. You always do. But again, if the first element only has one atom, you leave out the mono from the name. So this is not mononitrogen. This is just nitrogen monoxide. And the next one should be diphosphorus pentoxide. And the next one should be dicarbon tetrafluoride. And the next one should be carbon, not monocarbon, carbon dioxide. And the next one should be nitrogen, not mononitrogen, but nitrogen trihydride. Okay, let's move on. Okay, so naming acids. So the first thing you have to do is when you're looking at a compound, you need to recognize if you're working with an acid, because if you are, then you have to use the rules for naming acids. And so it's pretty easy to tell if you have an acid or not. If the first letter in the formula is an H, you have an acid, and you have to apply the acid naming rules. If it's not an H, it's either an ionic compound or a molecular compound, and you apply the rules which I talked about earlier. Now, it's broken down further. You have two kinds of acids. You have binary acids and oxyacids. So the binary acids are the ones where you look at the formula and there's no oxygen in it. It's just elements. Also, what you'll see is there are only going to be two elements in the formula, and that's why it's called a binary acid, because there's only two elements, again, without oxygen. Now, it has a particular set of rules to name binary acids. Oxyacids are a little bit more complicated. So if you see a formula with an H in front and there is also an oxygen in some number, it can be anywhere from 1 oxygen to 4 oxygen, you have something called an oxyacid. And then if you have an oxyacid, it is named with different rules than the rules that you use for binary acids. And so let me go through these in turn. Okay. So binary acid, again, let me remind you, it's an acid with an H in front, and there's another element and there are no oxygens. And so this is what you do. Let's say you have a formula and you see an H. Well, if you want to name that formula for a binary acid, you see the H, you would write hydro for the H. Then with the other element, you remove the end of it, of the root, or the end of the suffix, and then replace the suffix with ic, and then you add acid to the end. So I have some examples there that you're welcome to look at on your own, but I'm just going to kind of do this in a few moments. But I encourage you to stop the video and look at those examples so you can see how to name them. Okay, oxyacids are a little trickier. So an oxyacid is an acid with an oxygen element in it, along with the H in front. And so what you have to do is when you name an oxyacid, it's a little different than a binary acid. Remember with the binary acid, you include the word hydro. With the oxyacid, you don't mention hydrogen. You don't mention hydro. You look at the anion and you look at the root of the anion. So if the anion ends in ate, you change that to the suffix ic. If the anion ends in ite, you change that to the suffix ous, us. And then the final name includes the word acid at the very end of it. And so there are some examples here, but I think the best thing for me to do is just to kind of go over these examples I now have on the screen. Okay, so how do we know that these are all acids? Well, the way we know is that the first letter is H. And if that's the case, that's hydrogen, the first letter is an H, then it's an acid. Now you have to figure out whether it's a binary acid or an oxyacid and apply the appropriate rules. So the first acid is HF. I don't see an oxygen. There are only two elements in it. So it is a binary acid. And so you use the binary acid naming rules. And so the first thing we write is hydro. Now, the anion is fluorine. We change ene to ic. So it's hydrofluoric and then acid. So this acid was made famous in Breaking Bad. This is the one that the chemist dissolved tissue with, so you want to stay away from that one. Okay, number 2, HNO3. So it is an acid because there's hydrogen there. However, there's also oxygen, and there are 3 oxygens in that formula, so it's an oxyacid. So you need to know the oxyacid rules. So the first off, do you include the word hydrogen or hydro in the name of the acid if it's an oxyacid? The answer is no. Don't write hydrogen or hydro. Focus in on the anion, which I'm just going to put a bracket around. So let's look at the anion. Look at it carefully. And what I'm kind of hoping that you remember is that NO3 is nitrate. So if it is nitrate, you have to take 8 and change it to ic. So we take nitrate, change 8 to ic, and then we write acid. So let me just write it all the way out here. So this is nitric acid. Okay, the next one. Now, is that a binary acid or an oxyacid? I don't see oxygen in it. There's only 2 elements, and there's a H in front, so that is a binary acid. So this should be hydroselenic acid. Okay, the next one. Is that an oxyacid? Yes, there's oxygen in it. So we don't write hydro. Now you have to look at the anion here and remember what the name of the anion is. Is that sulfate? No, sulfate is SO4. This is FO3. This is sulfite. Now, if you have an anion that ends in ite, for the acid name you use OUS. You don't write hydro, so this is sulfurous acid. Okay, the next one is an oxyacid. The anion is sulfate, it's 8, so you have to change 8 to ic, so it's sulfuric acid. Now, the next one, is that an oxyacid? No, because there's no oxygen there. In fact, there are only 2 elements there, is hydrogen and sulfur. And so this is going to require the binary acid naming rule. So it's going to be hydro something. So it's going to be hydro, and then there's sulfur there. So it's hydrosulfuric acid. Okay, the next one is a little tricky because you may not recognize the anion. There's an anion here with an oxygen, so that would be an oxyacid that we're going to have to name. So what is that ion? So it is hypochlorite. So we have to get a name for this. So it's going to be hypochlorous acid. Okay, thank you for listening. We'll see you next time.